Okay, so we're going to be studying ratio and proportion. A ratio is a comparison of two quantities. So you can have A to B, A over B, A to B, all of those things. Those are all ratios. Proportion is a statement that says that two ratios are equal. Proportions are really important. So we have A over B equals C over D. Okay. You should learn proportions a long time ago. You should have also learned to cross multiply. So proportions to the statement that two ratios are equal. You guys should also know that A times D, when you have that equal sign, is equal to B times C. And there's a whole reasoning with that, but go over it. All right, so for this is to solve the proportions below, so I cross multiply, so that's going to be 5 times x equals 6 times 15. 5 times x equals 90. X equals 18. And so my proportion is 6 over 5 equals 18 over 15. And you should have learned in middle school that you can also use equivalents. I know that 5 times 3 is 15, so 6 times 3 would have given me that number there as well. Things to be careful of when you're solving a proportion, especially when you have a binomial in the denominator like this one. So when I cross multiply, this is going to be 3 times x is equal to 6 times the quantity x minus 6. Now this is really important because you need to remember to do distributive property. So this is 3x equals 6x minus 36. I'm going to subtract 6x from each side. I have negative 3x equals negative 36. Divide by negative 3. X is equal to positive 12. So that means that 6 over 12 is equal to 3 over 12 minus 6. And this is just my little check. Let's say, is 6 over 12 the same thing as 3 over 6? And we know that's true because it's a half. Now we're going to use some ratios and proportions. The ratio of boys to girls is 4 to 3. If there are 20 boys in the class, so boys over girls, okay, boys over girls is equal to, okay, we know that there are 20 boys and we're trying to find X number of girls, okay? So you can cross multiply. That's going to be 4 times x is equal to 3 times 20. 4 times x is equal to 60. Divide by 4, x is equal to 15. So there are 15 girls. Here's another one, just a little bit different. Again, we have the ratio of boys to girls, which is 1 to 3. It says in this case, though, it doesn't go by gender, okay? There are 28 students in the class, okay? So if my ratio of boys to girls is 1 to 3, my ratio of girls to the, girls to the class is going to be 3 to 1 plus 3. The 1 plus 3 comes from this right here. So my two parts were a 1 to 3 ratio, which is a total of 4. So my girls to the class is a ratio of 1 to 4. So I know girls over class equals, we're trying to figure out girls over class, which is 28. So I cross multiply. That's going to be 4 times x is equal to 3 times 28, which is 84. So 4x equals 84. Divide by 4. X is equal to 21. So there are 21 girls in the class, and so there's a third the number of boys in the class as girls. So therefore, there must be only 7 boys in the class. Okay. Triangle has the angles in the ratio of 1 to 2 to 3. What's the size of each angle? So this is what I want you to think about for these. So it's in the ratio of 1 to 2 to 3. So it could be, so numbers that would be in the ratio of 1 to 2 to 3 would be like 2 to 4 to 6. But I know that doesn't work because they have to be angles of a triangle. And I know that the angles in a triangle add up to be 180, and those do not add up to 180. I could do 4 to 8 to 12, because those are in the ratio of 1 to 2 to 3. But again, this can't be it because it does not add to 180. So one thing that you can do is, I know 1 times some number plus 2 times some number plus 3 times some number is going to give me 180. What I'm doing is I'm multiplying each part of the ratio by some number to get me to 180. So I just add this up, 2 plus 3. Sorry about that. This is going to be 6x equals 180 divided by 6. X is equal to 30. So my angles are going to be 1 times 30, which is 30, 2 times 30, which is 60, and 3 times 30, which is 90. Number 4 is something very similar. So the sides of a triangle, the ratio of 3 to 8 to 7, and the perimeter is 63. So you're given a ratio, you're given a total. Just throw an x next to it, so it's going to be 3x plus 8x plus 7x is equal to 63. Okay. So I add this up, 11, so this is 18x equals 63. I divide 63 by 18, and I get 3.5. So now x in this case is 3.5. So my sides, one side is going to be 3 times 3, 3.5, which is 10.5. And 10.5, excuse me, centimeters. Can't forget my units. The other side is going to be 8 times 3.5, which is 28 centimeters. And my last side is 7 times 3.5, which is 24.5. And if you add 24.5 plus 28 plus 10.5, you do end up getting 63 centimeters. All right, so proportions are really important when it comes to real life situations too. This is kind of an interesting one. The Greek mathematician Thales was the first to measure the height of a pyramid by using geometry. He showed that the ratio of the pyramid to the staff was equal to the ratio of one shadow to the other. So they're proportionate. So you can do, good Lord, you can do height over shadow equals height over shadow. And if we were live, we'd be doing an activity like this. Unfortunately, because we're not, we can't really do this. But basically, he figured out that at a certain time of day, this person right here was 2 paces tall and the shadow was 2 paces long. So 2 over 3. At the same time of day, this shadow and the height of the pyramid is going to be proportionate. And so they knew they could figure out the width of the pyramid and the length of the shadow. So that was going to be 125 plus 114, which is 239 paces. And we don't know what the height of the pyramid is. That's what we're trying to figure out. So x over 239. And we can cross multiply. It's going to be 3 times x equals 2 times 239. So again, height over shadow equals height over shadow. And so it's going to be 3x equals 478. I divide by 3. And x is equal to 159 and 1/3 pace is. Now it says a pace is about 3 feet. So I'm actually going to take this and multiply by 3 because I think it would be interesting to see. And so actually it's going to be 478 feet tall. So there's about 10 feet to 12 feet in a story. So just gives you an idea. It would be about 40 stories tall. Jose reduces a photograph that is 21.3 centimeters by 27.5 centimeters, so it would fit in a 10 by 10 centimeter area. Find the maximum dimensions of the reduced photograph. So what you need to do is you need to shrink down the largest dimension to the side here. Okay, because we want to be able to use a maximum amount of the paper. So I want to shrink down 27.5 to 10 centimeters. So my 27.5, I'm going to be shrinking down to be 10 centimeters. So my question is, my 21.3 side, how big will that be when I shrink it down? Okay, now I couldn't shrink this down to 10 because this would be bigger than 10. So that's why I'm setting it up this way. So I cross multiply 27.5 times x is equal to 21.3 times 10. So 27.5x is equal to 213. Divide by 27.5, divide by 27.5. X is equal to 7.7. Approximately. Okay, just about 7.7 centimeters. Last question is, what percent of the original length is the length of the reduced photo? Okay, so what percent is it? What kind of reduction would it be? Well, my new dimension was 7.7. My old dimension was 21.3. So it's going to be new over old. And 7.7 divided by 21.3 is 36%. And then you multiply that by 100, sorry, which would be about 36.1%. You could do the same thing with the other dimension. Your new length is 10, your old length was 27.5. You 10 divided by 27.5, and that is also times 10, or times 100, and that's going to be about 36.4%. Okay, so it's 36.4% of the original, which seems about right. And that's it.